Welcome back. You should now be on page 5 of your notes. Please make sure that you have this definition and all these units written down. Pause the video if necessary. Continuing, heat capacity, capital C. Please make sure you've written the definition of heat capacity down and all the information on this slide. Pause the video if necessary. Heat capacity, specific heat, lowercase c. Specific heat, lowercase c. Very important that you notice that specific heat is lowercase c, and going back, heat capacity is capital C. Very, very important that you know that. They are different things. Read those definitions and see if you can understand the difference. Notice the formula we have here for heat capacity. Heat capacity is capital C times delta T. We will be looking at heat capacity in much more detail later on. But I'd like you to note here that delta T is similar to the delta V we've been dealing with, where delta T is final temperature minus initial temperature. My ending temperature minus my beginning temperature. Also, on this slide, specific heat, you will notice that I have given you the specific heat of water, 4.18 joules per gram degree Celsius. That is on your blue card, and it's a number that you will become to know just because we'll use it so much. A couple other things you should know. You should know how to convert temperatures. Temperature conversions are here. If they're not on your blue card, I would suggest you pause the video and add them to your blue card. Alright, some more things to add to the blue card. We have a new formula. The formula for specific heat that involves specific heat is Q equals mass times C for specific heat times delta T. A couple things to notice. If temperature is increased in a specific heat problem, then look how the math comes out. Meaning, if temperature increases, for example, from 10 degrees Celsius to 90 degrees Celsius, then we say Ti, my beginning temperature is 10, and my final temperature is 90. So delta T then would be 90 minus 10, which is a positive 80 value. However, if it tells us that there's a decrease, or we know there's a decrease in temperature, then temperature decreases, for instance, from 80 degrees Celsius to 40 degrees Celsius, then the beginning temperature is 80, and the final temperature is 40. If I plug that into the delta T equation, then 40 my final minus 80 my initial gives me a negative 40 degrees Celsius. Let me repeat that. Delta T here would be, for the example we have, final minus initial. My final temperature was 40 degrees Celsius, and I subtract that from my initial temperature of 80 degrees Celsius, and I get a negative 40 degrees Celsius. Meaning that if temperature is decreased, you're going to have a negative temperature, and if temperature increases, you're going to have a positive value of temperature. Alright, so now we have three equations that we have used so far. We've been using this one, the E equals Q times W. We've used W equals negative P times delta V. And now we have Q equals M times C times delta T. Remember, I'm multiplying these three factors, so I could technically multiply them in any order that I wish. Alright, first example, example 4. I will pause the video here and actually give it back to you in another video clip. Thank you very much.